looking like tomorrow is not right. We've not seen the moon in Nigeria yet, and they've not seen the moon in Saudi and some other places. Kuwait has not seen the moon. Qatar has not seen the moon. UAE saw the moon. They said they are going to do it on Friday. So everybody doing it on Friday. So take the information as you think it would pay you. So don't fight your tailor. You might still have chance of going to your tailor tomorrow. So tell him not to do rush work. Okay, so let's start from question 9. I want to take it from question 9 and I want to solve all these questions so that we know that when we are coming to class after it, we are not going to be doing all this Newton's law, blah, blah, blah. I want to move to something different from these guys, hopefully. I'm tired of these topics. I've taught these topics and I'm very, very tired of teaching these topics again. I'm going to start from question 9. So maybe I should do 9 and 22 together because they are both, you can't see my screen. Rakib, you are truly with your tailor. I hope your phone, you are tailor your phone, come on screen phone. I hope that's not the case. Because every other person can see my screen. So I want to solve question 9 and 22 simultaneously. Do you understand? So I'll solve question 9 and 22 on okay, go. You get. So question 9. An arrow of mass 0.1 kilogram moving with a horizontal velocity. Now, an arrow of mass, so mass of arrow, I'll just write MA, mass of arrow. That is 0.1 kilogram. Moving with a horizontal velocity, velocity of arrow is equals to 15 meters per second. It shot into a wooden block of mass. So mass of block is 0.4 kilogram. Lying at rest, velocity of block is 0 because that block is not moving. You understand? It's not a moving block. I think we have solved this question. I think that was why I wrote 3 meters per second under it. Their common velocity after impact is common velocity after impact. Very simple. Because momentum is conserved, we know that total momentum before is going to be equal to total momentum after, right? Total momentum before we equals total momentum after. What does that mean? That means that the mass of the arrow, 0.1, times its velocity, 15, plus the mass of the block, 0.4, times its velocity, 0, will be equals to mass of block plus mass of arrow multiplied by common velocity. Because when you shoot a chalk, both the block and the bullet are going to stick together, right? They are common velocity. That's why they are going to have common velocity. That kind of momentum is what? Inelastic. So here we have 1.5 plus 0 is equal to 0.5 V divided by 0.5 divided by 0.5. So V is going to be equal to 3 meters per second. And that's the answer. Option G. Question 22. Two balls X and Y weighing 5 grams and 50 kilograms respectively were thrown vertically at the same time with a velocity of 100 meters per second. How will the operation be 1 second later? I think we have solved this question too. Okay, we solved the one that has to do with pressing a brake. I think it's that pressing a brake one. I'm not sure we have solved this one. Question 22. Okay. Two balls X and Y weighing 50 gram. Now, I'm looking for, who is that? I'm looking for network. Oh, sorry. Question 22. Two balls X and Y weighing 5 gram and 50 kilogram. Ball X, ball Y, 5 gram, 50 kilogram. Let me draw this one to be very big. Were thrown up vertically at the same time. So we throw the two of them up. Now, from one of the things we learn is that when you throw an object, either up or down, at the same time, using the same speed, it's going to take them the same time to get to their what? To their maximum height. Coming down to the same thing, they will fall at the same rate. Do you understand? So, in the absence of air resistance, note, in the absence of air resistance, this fall or rise with the same acceleration due to gravity, regardless of their mass. Do you understand? Regardless of their mass, all objects will fall with the same what? With the same acceleration due to gravity, irrespective of what? Of their mass. Do you get that? So if you are 50 kg heavy and you are 5 gram, this 5 gram, we have to convert it to kilograms. So we divide by 1,000. That would give us 0.005 kilogram. That's very, very small compared to 50 gram. This one is like bag of rice. And this one is like, let's say, camphor. You all know camphor, Abby? Yes. Let's think of it as that's camphor, that's small camphor. And a bag of rice. Some of you are going to cook bag of rice in it very soon. So if you have location of bag of rice, please don't hold the information or invite us. Tell us that we can come and eat with you and your family. Thank you. Don't keep it, oh, please. Don't waste rice. Don't waste it. Invite us. Tell us. So if the object is 0.005, like camphor, and a bag of rice, like the bag of rice, you know, that big bag of rice, if you throw it up, it is going to go up and fall at the same what? At the same time. So in the absence of air resistance, all objects or all bodies fall or rise the same g, regardless of their what? Of their mass. Do you understand? So we now have that, we have these two bodies. We are thrown up vertically at the same time. So we throw them up at the same time with a velocity of, so the U now is 100 meters per second at same time. How will their positions be 1 second later? Now, for ball X, It is going to be, let's use, because we're looking for position distance, we use UT minus half GT squared. Why am I using minus? Because we are throwing it up against gravity. That will be 100 times T. Let's use T to be 1 because it says 1 second later, 1 minus half G is 10 times T squared, 1 squared. So 2 year 1, year 5. Here we have 100 minus 5, which is 95 meters, right? If you calculate for ball Y also, you can see that we are not using mass. It is also going to be 95 meters. You understand? Because there's nothing that has to do with mass. So the position of ball Y also be, so it says X will be 500 meters ahead of Y. No. X and Y will both be 500 meters from the point of throw. I think we have solved this question. I think you have solved this question. X and Y will be 500 meters from each other. No. Y will be 500 meters ahead. No. They are going to be at the same point. Why did they not say 95 meters? The reason is because they could have used a different time. Do you understand? So what we are looking for is that it is saying that the same will both be 500 meters from the point of O. The same. That's what we are looking for. We're looking for the same. Do you understand? And that is option B. Is that clear, everyone? Any questions so far before we continue? Not everybody is now aware of this class, so that's why most of us are not available. Can we continue, please? Atia, Hamida.
Huh?
Who are on the call? Atia, Hamida, and this call. Okay, just 3 people. Aisha. Aisha, how are you? Question 10. A body of mass 2 kilograms moving vertically upward. Body of mass 2 kilograms moving vertically upward has its velocity. So let's write out the parameters. Mass for question 10. Mass is 2 kilograms. Moving vertically upward is going up. Has its velocity increased uniformly from 10 to 40. So U is 10, V is 40. In 4 seconds, time is 4 seconds. Neglecting air resistance, calculate the upward vertical force acting on the body. This is very simple now. We have to calculate force, and force is equals to MA. A is V minus U over T. That's what we use. So we say 2 into bracket 40 minus 10, that's 30 over 4. 2 year 1, year 2, 2 year 1, year 15. So our F is going to be 15 Newton, most likely. Is that clear? Newton. Question 11. In free fall, a body of mass 1 kilogram drops from a height of 125 meters from rest. How long will it take another body of mass 2 kilograms to fall from rest from the same height? You can see the same idea. A body of mass, so the mass of that body is 1 kilogram. Drops from a height, the height is 125. From rest, U is 0 and T is 5 seconds. How long will it take another body of mass How long will it take another body of mass 2 kg to fall from rest from the same height? What's the answer to that question? Question 11. The body has mass 1 kilogram and it was dropped from a height. How long will it take another body of mass 2 kilograms? Forget this 2 kilograms. Provided that it is from the same height, it will take it 5 seconds also to get down. Neglect the what's it called? Neglect the air resistance. Do you understand? Or the mass. Irrespective of the mass, this is the clue here. In the absence of air resistance, all bodies fall or rise with the same G, the same T, from the same H. Do you understand? So it will not change. That's for question 11. So we've done 10 and 11. Let's do 23 and 24. Question 23. It says, a man standing on a spring scale placed in a lift. The lift descends at constant velocity. It is coming down. That's the meaning of descent. That's the only grammar I can take from that question. The lift descends, it comes down. As a result, the scale reads a weight A greater than the weight of the man. B, the same as the weight of the man. C, of 0. D, less than the weight of the man. My network is good. Okay, you have to maybe wait for what's it called? The recordings. Actually, I can see my screen. I know that I can see my screen as well. Excellent. Okay. So for question 23, a man stands on a spring scale placed in a lift. Now that lift descends at constant velocity. Now, at constant velocity, this is what you need. And the fact that it descends. Remember when we discussed about the weight of lifting of an object? Let's go up and check. He said, when it comes down, the object feels lighter. Right? I said, when it goes up, the object appears heavier. What is going on? Why is it appearing heavier? Because it is going against gravity. So you feel like the thing is working. The lift is working, it's working against the norm. When it is coming down, you feel like it is not working, it's just normal thing. Even if you leave the lift, it will come down. You understand? It is working with gravity. That's why it feels light. But when the cable just breaks, it breaks off, what happens? So now we have the idea. Let's come back to the question and see what's going on. Now, this question is saying that the lift descends, it comes down at constant velocity. When something comes down at constant velocity, remember at constant velocity, what is happening at constant velocity? It is as if it is not moving. You remember? As a result, the scale reads a weight A greater than the weight of the man. No. It is coming down, so it will appear light. So A is wrong. It will not be greater. B, the same as the weight of the man. Let's keep this one first. 0. Less than the weight of the man. No, it will not be less than. So the correct answer is the same as the weight of the man. That's what the scale is going to read. It's going to read. Because it will be as if your tension is equal to what? To your weight. Because it is coming with what? Constant velocity. So the tension is going to be equal to the weight. Question 24. A 1,000 kilogram elevator is descending vertically with an acceleration of what? Of 1 meters per second square. If the acceleration due to gravity is this, the tension in the suspending cable is, we'll solve this question, but let's do it again. The formula we are going to use is T is equals to mg minus A. Why is G minus is coming down? You come back to this equation, you see when it's coming down. Can you see the formula? Mg minus A. If it's going up, mg plus A. Don't stress yourself. That's how you code it. So here it is coming down. That's why I'm using mg minus A. So our m is 1. Sorry, our a 1,000 kilogram elevator, that's 1,000. Sending, so we say 1,000 G is 10 minus 1, which is 9. So 9 times this, that's 9,000 Newton. Option C, and that's the answer. Now let's move to question 11. No, question 12. A bullet fired at a wooden block of thickness 0.15 m manages to penetrate the wooden block. This question is not a straight momentum question, but let's solve it. A bullet fired at a wooden block of thickness 0.15. Question 12. That's what I'm solving. Oh, I want to be able to write on this screen. The way to write is far. I'll have to rub off this one. So. Oh, God. Okay, let's do something. I'm not solving question 12. I want to solve it on this. On this place I'm cleaning. So it says bullets fired at a wooden block of thickness 0.15 m. That's going to be the distance. Forget about thickness, it's distance, 0.15 meter. The block. So the thickness from here to here is distance. Do you understand? That's why I prefer to say distance. Or let's say thickness. C. Okay. Manages to penetrate the block. If the mass of bullets is 0.025 kilogram, and the average resisting force of the wood, is what? 7.5 times 10 raised to power 3 Newton. Calculate the speed of the bullet just before it hits the wood. We have to calculate the speed. Let's say velocity. Let's not say speed. Let's say velocity. Velocity v of the bullet. The velocity that the bullet is using to run. Now, for this question 12, it's a bit different from the momentum question, but since we saw it, we don't have a choice. Let's solve it. Now, there's a formula for work. Work is equals to force times distance. I believe that this is not the first time you're hearing this. That work is equal to force times distance. Abby? Good. Now, this work is the same thing as energy. You all agree with me, Abby? Remember? From the first things we studied, work and energy are the same. Abby? Good. Now, this work, we have the formula of work. Since the work is the same thing as energy, we can change that work because we have force and we have the penetrating distance. That's the thickness. Remember, I told you that distance is the thickness. But that work, we can get energy, which is half mv squared. We can use this formula for kinetic energy. We have mass. We are looking for velocity. You can see the way I am putting the formulas together to get to our final destination. So I'm going to change this work to half mv squared now. And my force is 7.5 times 10 raised to power 3 times my distance, which is 0.15. So what I want to look for is m. So I'm going to transfer 2 to this side. So my m would divide and come here. So my v squared is going to be equals to 2. This 2 that I transferred here times 7.5 times 10 raised to power 3 times 0.15, all divided by the mass now. You know the mass was initially here. I want to bring it here, so it will be divided by, what's the mass? 0.025. Now, let's use our calculator. So let's do the numerator first. 2 times 7.5, that's 750. Yes, 1, 2, 3, yes. Times 0.15. That gives us 2250. Now this 2250, let's divide it by the denominator, 0.025. That gives us a 90,000. And we are to get the square. So we have to do v squared is equal to 90,000. So we take square root of v, take square root of v. So v is equal to 300 meters per second. And that's the answer. Do we get it? Do we get it? So for question 25, because we are doing it simultaneously, a man, I've done question 12 now. I want to go to 25. We've done 24, 22, and we've done 9, 10, 11, 12. Yes. A man standing on a lift that is descending does not feel any weight because, good. I've answered this question. 25. Why? What's the because? I want you to think. Tell me. What's the because? A man standing on a lift that is descending does not feel any weight because A, there's no reaction from the floor of the lift. B, there's no gravitational pull on the man in the lift. There's a gravitational pull. This is a lie. The inside of the lift is airtight. Nope. The lift is in vacuum. Nope. This is not the answer. The answer is this. There's no reaction from the floor of the lift. There's no reaction up. Remember that when we give you the formula, we used to tell you guys that the formula is T is equals to W, R, and all of those things. This reaction is negligible. That's why a man standing on a lift that is descending does not feel any weight because of weightlessness. And weightlessness means no reaction force. That's it. Weightlessness. It means what? No reaction force. That's why when you say when we say that there is weightlessness, you know, that object is just going. There's nothing pushing it back. There's no reaction force dragging it down. Remember that forces must balance. The upward and downward force must balance. So when something is weightless, it means that we only have one upward force. There's no reaction force bringing it down. Do you understand? So question 13 and 26 now. For question 13, a lead bullet of mass 0.05 kilogram is fired with the velocity of this into a lead block of mass, given that the lead block can move freely. The final kinetic energy after impact is so we have to calculate momentum to calculate the final velocity. We cannot use that to calculate the final kinetic energy. So from here we have to calculate momentum first. So let's do something that we did earlier. So for question 13 now, we know that the mass of the bullet, the mass of the bullet is 0.05 kilogram. Velocity of the bullet is 200 meters per second. Mass of block, good. So we just say mass of bullet 0.05 times 200 plus mass of block, but the block is going to stand. So it means that that part is even negligible. So we can say this is equals to, because that part will give us 0.05 mass of bullet plus mass of block 0.95 V. We can calculate V here. So let's do the calculation. 0.05 times 200, 10 divided by, this will give us 1. So our velocity here is, so this 10 is equals to 1 V. So our V is equals to 10 meters per second. The question wants us to find the final kinetic energy after impact. Kinetic energy is half mv squared. That's kinetic energy. So we are going to say half m, the two masses together, 0.05 plus 0.95, which is 1, then 10 squared. So this will give us 1 times 100 divided by 2. 2 in 100 is 50. So our answer is 50 joule, option A. Is that clear? Is that clear? Good. First one, we are not giving U. What do you mean by U? For the first question, we have mass of block. We have velocity of 200 meters per second into a lead block of mass 0.95. This lead block, because it's a block, it is going to be at rest. Do you understand? That's why we are saying that the U here is 0. So 0 times this is negligible. That's why I did not put it here. But we have the initial velocity for the bullet, 0.05, then 200 meters per second. That's the only thing I multiply together to get 10. Do you understand? Exactly. Good. So let's quickly look at question 26 like that. Which of the following is not a force? So which of this is not a force? Friction is a force. Tension is a force. Force in string. Upthrust is a force. Yes. Upthrust is a force. What kind of force is upthrust? When we get to equilibrium of forces, we'll talk about that. You can say I said equilibrium of forces. Upthrust is a force. That's why we talk about upthrust. When we talk about Archimedes principle. Impulse is not a force. It is just a force effect. Can you see the difference? Impulse. It's a force effect. Effect is force lasani. It is not itself a force. A force is an agent that causes change or tends to cause a change in what? In the motion of an object or the state of rest of an object. That is what we call force. When this force happens, what is the effect? That is impulse. Do you understand? That effect that you feel in the presence of the force is what? Impulse. Friction, tension, upthrust are all forces. That question is a very sweet question. Question 14. Two bodies have masses in the ratio 3:1. They experience forces which imparts to them acceleration in the ratio 2:9. Find the ratio of the forces in the masses experienced. I think we've solved this question 1 to 4. I think we've solved this question. Yes. Let me go and find it. We have solved it. I think we have solved that question. I can't see it, but I think we have solved it. It is resonating. It is resonating with me as if we have solved it. So after it's very simple. Two bodies have masses. So let's just say F is equals to MA. So I'll just say F is equals to MA. Two bodies have masses in the ratio 3:1. So I'll put 3 here. I'll put 1 here. Body 1, body 2. They experience a force which imparts to them acceleration in the ratio 2:1. So 2:9. Do you understand? Find the ratio of the forces. So here, if you do 3 times 2, you get 6 here. Here, if you do 1 times 9, you get 9. So what's the ratio of this 6 to 9? So just do 6 ratio 9. 3 will go in 6, 3. Sorry, 3 will go in 6, 2. 3 will go in 9, 3. So the ratio is 2 to 3. That's the answer. This is how I did it. I just used the formula F equals MA. I placed what we were given, I placed them beside each other, and I was able to get the ratio of the forces acting in between the objects. No be so?
That's true.
Nah, so Lucky, thank you. Correct guy. For question 27, there's a small wahala in question 27. But I've not explained to you before. I'm not sure we looked at, and no, it's not actually difficult. It's not difficult too. It's not difficult at all. We will look at it now. Why is my sister leaving? Atiya, where are you living? The acceleration of the system shown below is this. This object, this force, is being dragged up with a tension force at a particular angle. So there's something we call connected bodies. This one is connected to a 30 kilogram mass, and they are both attached at this point. It says the acceleration of the system shown below is, so we call it connected body. The system consists of a 20 kilogram mass, but that 20 kilogram mass is on a horizontally inclined surface. It is connected to a 30 kilogram mass on a smooth inclined plane, 30 degrees. Abi? This one, 30 kilogram. That 30 kilogram is on a slope. So it is going to slide down the inclined plane. I'm solving question 27. That 30 kilogram is on a slope. So it's going to slide down the inclined plane. But that 20 kilogram is on a flat surface. So it's going to be pulled. So which one is driving which one? 30 kilogram. Yes or no? So this one is the only one causing motion. This one. So let's calculate the force here. The force is going to be mg sine theta when we resolve it. Don't worry. When we get to that point, you will know how to resolve it. But for now, do Babet's theorem. F is equals to mg sine theta. What is our m? 30. What's our g? 10. Then sine what? 30. Sine 30 is half, 1 over 2. So use these two to divide the 10. That's 5. 5 times 30, that's 150 Newton. We have calculated the force. But we need to calculate the total mass in this system. What's the total mass? The total mass is 30 plus 20, which is 50 what? Kilogram. Now, our acceleration is going to be F over M, which will be what? 150 over 50, which will be 3 meters per second square. And that's the acceleration in the object. There's no 3. There's no 3 there. But we have 2, we have 4, we have 6, we have 8. Wow. Yes, probably the speaker. So it's supposed to be 3 meters per second. So in this case, now what are you going to pick? Let's assume you solve the question like this and you did not find the answer. What are you going to pick? And there's 2, there's 4. Assuming there's no 2, there's no 2 close numbers now. You have picked the one that is very close. Okay. Let's use 9.8 here and see. Let's use 9.8 here. Hello, Tafaya. Let's use 9.8 and see. 30 times 9.8 divided by 2. will still be the same thing. And 47 divided by 50. So it's 2.94, which is still 3 meters per second. Sorry, 3 meters per second. Okay, we'll come back to that question. I will confirm if it is an omission from the options, or maybe the workings I did is wrong. 150 by 30. 150 by 30. That's still 5 meters per second. Okay. Let's come to question 15, please. We've done 27 before, 28 also. We've done 28 before. I remember doing 28 with you guys. So let's come to question 15. A catapult used to hold a stone of mass 500 kilograms is extended by 20 meters, with an applied force F. If the stone leaves with the velocity of this, find the value of the force. That thing is very simple. But it needs like 2 formulas. So let's come here and let's solve it. Let's see. Okay. Let's write out our parameters. A catapult used to hold a stone of mass. The mass of the stone is 500 grams. So let's take it to kilogram, divided by 1,000. That would be 0.5 kilogram. Is extended by 20 centimeter. That's the, what can we call that? Extended by, that's the distance. S. 20 centimeter. Convert to meter, divided by 100. That would be 0.2 meters. With an applied force F, if the stone leaves with a velocity of, so the V is 40 meters per second. The value of F is, we have to find the force. So from the values that we have, we can use V squared is equals to U squared plus 2AS to calculate A. Then we can now use F is equals to MA to calculate force. But in this case, the catapult is used. So when you want to catapult something, initially the object is going to be at rest. So our U is 0. Can you see the idea? Anybody that's used the catapult before, you agree with me that you have to draw the wire back, hold it for a while before you now release it. Do you understand? So it means that at that point when you are holding the rubber or the, what do they call that thing? Rubber none. At that point you are holding the rubber, the initial velocity is 0. So we say V squared, which is 40 squared. So let's say 40 squared is equals to 2 times A that we are looking for times 0.2. So divided by 0.4, divided by 0.4. So 2, 0.4, 0.4 will go. So our A is going to be 40 squared. Calculator. Don't stress your brain, please. 40 times 40 divided by 0.4. That gives us 4,000. Our acceleration is 4,000. So F is equals to MA. Our M is 0.5 and our A is 4,000. So 0.5 times 4,000, just say times 0.5, and that gives us 2,000 Newton. That's our force. Option C, 2 times 10 is power 3. So it's not this 3. Question 16. If the total force acting on a particle is 0, the total force acting on a particle is 0, the linear momentum will, remember that force is equals to what? Change in momentum, right? So we are saying F is equals to mv minus mu. This force now is 0. So we say 0 is equals to mv minus mu. That's like saying the velocity before is equals to the velocity after. So if the total force acting on the particle is 0, the linear momentum will increase, then decrease. Be constant. That's the answer. Increase, no. Decrease, no. No. It is going to stay the same. Velocity before will stay the same as velocity after. Can you see that? This is asking you for what? Your understanding of conservation of momentum. It's asking for your understanding of conservation of momentum. Question 17. A body weighing 80 Newton stands in an elevator that is about to move. About to move. The force exerted by the floor on the body as the elevator moves upward with an acceleration of is move upward. Our tension is going to be mg plus a. Remember, move upward. A body weighing 80 Newton. If it is weighing 80 Newton, the mass will be 8. That's 80 divided by 10. So the mass is 8. Then our g is going to be 10 plus acceleration is 5. So we have 15 times 8. 15 times 8. That gives us a 120 Newton. Question 17 is B. Is that clear? Question 18. A force of 100 Newton is used to kick a football of mass. Find the velocity with which the ball moved. We've solved this question, I remember. Question 19. Jet-propelled aircrafts. Rocket propulsion. The recoil of a gun. A person walking. Which of the above is based on Newton's third law? Jet-propelled aircraft, yes. Rocket propulsion, yes. The recoil of a gun, yes. While walking is possible, yes. So the correct answer is 1, 2, 3, and 4. 1, 2, 3, and 4. Option A. All are the application of Newton's third law. You might need to go and read Newton's third law from new school physics. Go and read it. You also need to be reading. You should not be giving you everything. Question 20. A force of 200 Newton acts between two objects at a certain distance apart. Force of 200 Newton acts between two objects of a certain distance apart. The value of the force when the distance is halved is so. A force of 200 Newton acts between two objects at certain distance. So we have two objects. Boom, boom. A force of 200 Newton acts between two objects at certain distance. The value of the force when the distance is halved. This distance now, we now half it. So that the distance is now like this. Now as if they are like this. Apart. Before, the value of the force is 200. When we now half it, what will happen? So it is very simple. There's something called the inverse square law. Remember, F is equals to gm1 m2 over r squared. This is called Newton's universal law of gravitation. It is in SS3 topic. If you open to new school physics, you are going to see it in chapter 2 or chapter 3, new school physics. dm1 m2 r squared. It is called the universal law of gravitation. It is Newton that postulated this law as well. What you need is just this F and R squared. How do I mean? Let me come here. I'm going to solve question 20 here. Question 20. F is equals to 1 over R squared. F is 20, Abi? Sorry, 200. Then R is 2. Because it says the distance between them is halved. Halved. Do you understand? So it is not 2, sorry, it is 1 over 2, sorry. Halved. So you just say 200 is equals to 1 over half squared. Do you understand? So 200 let's do it this way. Let's do it this way to make it relatable. Let's say we have our old force, new force that we're looking for, force times 1 over R squared. So we say 200 times 1 over 2 squared. So let's solve this now. Let's start by doing 1 divided by 2, 0.5. So times 0.5. That gives us 0.25. Now let's divide 1 by 0.25. That gives us 4. Then let's multiply it by 200. That gives us 800. That's the answer. 800 Newton. If you don't know how I press that calculator, let me show you again. I started with the half. I want to do the half first. 1 over 2. Remember that 1 over 2 is squared. So I did 1 over 2. What is 1 over 2? 1 divided by 2. That gave me 0.5. So I want to now square it. So 0.5 times 0.5. I've squared it. That gave me 0.25. Now I want to divide 1 by it. So 1 divided by 0.25. So 1 divided by 0.25. That gives me 4. So all of this guy here now is 4. Then times 200, that's 800. That was how I got that. Question 21. I'm going to stop in 3 minutes. A star and a feather are drawn from the same height above the earth, ignoring air resistance. Which of the following is correct? They are going to get to the same time, to the same height at the same time. That's the answer. Question 21. The stone and feather will both reach the ground at the same time. Yes, because ignoring air resistance. I already told you, irrespective of the mass, they're going to get out at the same time. So let's come to question 20. Let's start from 32. Let's take it up. Tired. A rope is being used to pull a mass of 10 kilograms vertically upward. Determine the tension in the rope. 32, 31, 30, 29. Go and solve it by yourself. I'm tired. Amida, thank you. You already want me to leave, Johnson. Thank you. So we'll see in the next class, Inshallah. Nancy. So let's leave the call so that the recording can stop. Let's leave the call, please. Amida. Oh, no problem.